Hi everyone, welcome. We're going to talk a little bit about really foundational numeracy skills for early learning, focused on kindergarten and grade 1. So let's get started. The first thing I want to start with is this framework called the Development of Mathematical Reasoning by Pam Harris. What this does is it outlines that development of how kids think and reason about numbers as they move up the grades and as they continue to learn and grow. Um, and so what we're going to really focus on here in kindergarten and grade 1 are the counting strategies and then nudging kids up into additive thinking. When kids have a really strong understanding and mastery of counting, then they're better able to start grouping numbers together into additive thinking. And once they have additive thinking really mastered and they own that, then they are better able to jump into multiplicative thinking and so on, and really build strong numeracy foundations as they move through school. So building those counting strategies in kindergarten and grade 1 is so essential. So let's first start talking about counting strategies. This is a base of our development. And counting strategies are anything where we're counting by one. So 1, 2, 3, 4, counting down 4, 3, 2, 1, or counting on 4, 5, 6, 7 from different numbers. These are counting strategies. And there's a lot that goes into counting strategies, which we'll get into. But kids really have to understand counting and quantity and the way that numbers move up and down for them to get into more sophisticated ways of thinking. So in kindergarten, we live in counting strategies. Don't have to focus too much on additive thinking, but we can start noticing some of the additive thinking pieces. In grade 1, we want to really reinforce counting strategies at the beginning of grade 1 and start nudging kids up into additive thinking by noticing and providing opportunities for additive thinking. But grade 2 and 3 is where additive thinking really gets honed in and refined. When we move up to additive thinking, what this means is we're now grouping numbers together. We're not thinking about numbers as individual 1, 2, 3. We're not thinking of numbers as groups. So an example of additive thinking is doubles. Right? 2 plus 2, 3 plus 3, 4 plus 4. We're now thinking of those as two equal quantities that we're putting together. 3 and 3. When we put those together, we have 6. That's additive thinking. Another example of additive thinking is things like friendly tens, right? We have 7 and 3. We put those together, we get 10. We have 9 and 1. We put those together, we have 10. So this is where we want our kids to be starting to develop by the end of grade 1. So those counting strategies are really essential for kids to move up this landscape of reasoning. Sometimes kids get stuck. I've had kids in grade 6 who should be working on refining multiplicative reasoning, but they're actually stuck in counting strategies. And so they're multiplying by counting by 1. So we can have kids at any age or grade stuck in a less sophisticated way of thinking. And so what we want to do is build them up to more sophisticated ways of thinking about numbers. So how do we do that, and what are counting strategies? Let's get into it. Okay, this image that you see on the screen here is called the landscape of learning for number sense. And there's a lot going on this page. It's kind of overwhelming, but we're gonna really narrow it down here. We're not gonna understand everything on this page. I just want to give you a general idea of how kids learn number sense and what some order to number sense acquisition might be. So if we look at this page, we're really going to focus down on this lower landscape here. So let's just focus down on this part here. This landscape we can think of as like a path, like we're driving down a road, and kids all take a different path. So they start at the bottom of this landscape and they work their way up through the landscape. Now, every kid is going to take a different path. It's not clear cut. And sometimes they're going to miss things, right? Sometimes they're going to bypass something, or sometimes they have to do a U-turn and come back and reacquire that. And sometimes as teachers, we jump ahead and try and teach something too complicated for what they're ready for. And so again, kids miss that piece. So we have to U-turn and backtrack a little bit. Sometimes when we're trying to teach something as well, and a student's not understanding or the whole class isn't understanding, this landscape can help us to look and see what we need to go back on and review. so that students can get the understanding that they need. So let's start here at the very, very bottom of the landscape. What do you see at the very bottom? We have my favorite word. We have down here, subitizing. So what does subitizing mean? Well, subitizing is being able to recognize a number without having to count it. So, for example, if we look at these dice patterns are great examples. We can just look at this and we can say, okay, we have 1 and 2. That's 2. This one here, kindergarten, the kids have to be able to subitize until 5. So we should be able to look at this and say that's 5. Now the 6 is interesting. If kids can't subitize the 6, is there something within there they can subitize? Can they subitize the 3? Can they say, oh, that's 3? And then we have another 3. That's kind of cool. So while kindergarten doesn't have to do up to 6, it would be interesting to compare these 3s with that 3. Oh, look, they're in different orientations. That's kind of cool. So any opportunities to show kids dot cards and dot patterns to be able to count and then identify how many are on that page. That's what we call subitizing. Now, kids don't necessarily enter there because you have to be able to count a little bit before you can subitize. So kids typically enter over here in counting or maybe over here in magnitude. I should say too, sorry, that any of the rectangular bars, this is written on the bottom of the page, the rectangular bars are strategies. So this is what we want our kids to actually do. So we're going to focus on the rectangular bars. The ovals are big ideas. So this is what kids know. We don't teach this. We help kids to build an understanding of this. It's not what we do, it's what we know. And then the triangles are models and visuals, ways that we can visualize this. Sorry, I should have said that before. So counting in magnitude. Magnitude is a big idea. It's in an oval, and this has to do with comparison. So like the school bus is bigger than the car, or this teddy bear is bigger than this doll, or that that table is longer than that desk. So it's that idea of comparison where something is more of something or less of something than another. This is also a kindergarten outcome in the new math curriculum. So kids might just enter with that comparison. So lots of comparing in kindergarten. Now counting over here is that one counting by ones, like we were talking about before. 1, 2, 3, 4. And we have over here too one-to-one tagging. And synchrony means one word for every object. So this means that when kids are counting, they're actually tagging the object. 1, 2, 3, 4. That's one-to-one tagging. We want to make sure that kids can do that. So lots of practice with that. Synchrony means that we're assigning one word to every object. You might have seen kids before where you want them to count a set of things and they go 1, 2, 3, 4, 5, 6, 7. And they're not assigning one-to-one correspondence here. So we have to make sure that not only can they tag the items as they count them, but they also will only assign one word to each. And that one-to-one correspondence is there too. So some ways that we can do that, things like modeling with tallies, modeling with dots, and lots of counting. So always counting sets, always, let's count the number of students, let's count the number of people at this desk, let's count the number of everything. We're always counting. Cardinality here is another interesting one, and this is part of the numeracy screeners as well. What cardinality means is that when kids are counting something, whatever the last number is that we say, this is the total. So for example, if we're counting these dots, kids would say 1, 2, 3, 4. So that's great counting, but how many are there all together? And so if you have a kid that answers that question by going, yeah, there's 1, 2, 3, 4. That's great counting, but how many are all together? And so that student might be missing that idea that the last number that we say, that 4, also indicates the total. They haven't really associated that there are 4 things altogether. They're just going back to counting. So every time we count something, we also want to ask, great, counting. So how many are there altogether? And reinforce that there are 4 dots altogether. The last number that we say is the total. So one that can kind of get missed a little bit here. Lots of modeling of actions, lots of modeling of situations here, lots of trial and error, right? So you can see that counting is really, really important in those early years. Now, one piece that often gets missed, it's quite challenging, and I find this is a challenge for kids all the way up into grade 3, 4, sometimes even grade 5, 6, is counting backwards. This is a skill that often kids practice, but they don't necessarily own or master. So kindergarten, this is in your curriculum, grade 1 as well, it is in your curriculum. Really reinforce counting backwards. Kids will never learn the idea, the concept of subtraction if they don't understand counting backwards. So I would start with counting forwards, but then also bring in the idea of counting backwards. You also have to bring on counting on. Counting on is when we say start at a number like 5 and we go 5, 6, 7, 8. Now you can see that there's lots of work that happens before we get to counting on. So kids might not be ready for counting on. Make sure that they're pretty masterful at counting and counting backwards before we get up to counting on, because that one is a little bit more, it's higher up the landscape, as you can see. Now, a couple that usually surprise people is skip counting. Can you find skip counting on the landscape? I'll help you out here. Skip counting is way up here. Now, skip counting is something that we often associate as a very foundational skill. But let's think back to our landscape, right? If we go back, remember that counting strategies are counting by 1, 1, 2, 3, 4. Additive thinking is when we group numbers together and count things or represent things as groups of numbers. So is skip counting a counting strategy, or is it additive thinking? It's additive thinking because we're grouping 2s together to count by 2. We're grouping 5s together to count by 5. Skip counting is actually in a whole other level of sophistication than counting skills, and that's why it's so high. In fact, and this really surprised me and often surprises teachers when we look at this landscape, look at where doubles is. Remember I said doubles is an additive thinking strategy? Well, it's probably the most foundational additive thinking strategy because we can start doubling numbers and that kids tend to grasp onto that really easy. But notice how doubles is easier than skip counting, or I mean lower on the landscape. Why do you think that is? Well, when we double something, there's 2 of them. When we skip count by something, it goes on and on and on infinitely. So skip counting is actually a really challenging concept. Kindergartens don't skip count. It's not in your curriculum. It's in grade 1. And grade 1 teachers don't skip count until later in the year. They have to master counting strategies before you even start to introduce skip counting. You can model it, you can introduce it, you can notice it, but we don't even need kids to master skip counting in grade 1. We just need them to master counting and start thinking in doubles and thinking in groups. The other one that's quite high on here is making tens. It's about equal to skip counting on the landscape. Again, making tens is additive thinking because we're grouping numbers together. So kindergarten, you don't need to get here. Okay, I would get as high as counting on, and then I would just introduce the concept of skip counting and making tens and doubles as interesting things to notice, but modeling as the teacher, not necessarily having kids do the work. Grade 1, you're going to really reinforce counting for like most of the year. Like we're talking, well, all year long. We should always be counting from September to June, but starting to introduce these additive thinkings like doubles, skip counting, making 10, probably, I don't know, by Christmas, and really reinforcing them after that, but constant work. There's no skip counting unit. It's constant. It's every single day. The other one that I want to point out here is 10 frames. So first we have uses 5 structure. Oh, and then here we go. Couldn't find it there. 10 frames. These are the 10 frame is a model. So 10 frames are something we want to introduce pretty early on, and kids don't have to be using the 10 frame, we can just be modeling with a 10 frame. And we really want kids to understand that, like, this is five. Like, we really have to look at different interpretations of five. See the five dot pattern above in the dice? Well, this is also five, right? This is also five. But is there a way that we could create five in another way? Like, could we create five like this? Whoops, sorry, I changed the color here. Is that also five? Can you think of other ways to make five? So introducing these 10 frames just helps kids to understand. It's going to help them nudge into additive thinking because it helps them to understand that these sets of fives and tens are a set. And so the more we can work with 10 frames, the better. The other thing that you can work with a lot are the reckon recs. The ones that I love, I should have put a picture in here, but they're essentially like a 2-level reckon recs, and there's 10 dots, right? Or 10 beads on them, on both, and 5 are red and 5 are white. And again, reckon recs really help kids to make sense of numbers and start to see patterns and connections. Kindergarten and early grade 1, the kids don't ever have to touch a reckon rec. This is all our modeling. I have a PD session about reasoning with reckon recs on EPD if you want to get more into reckon recs. That's a really important one. So that's our landscape of learning for number sense. I'm not going to go any higher than that. But again, if kids are kind of stuck somewhere, or if you want to learn more about this, you can email me and ask, or even Google some of these concepts and you'll be able to find lots of information from them. But I guess the idea here is that we never stop counting. We never stop representing numbers. There's no units when it comes to numeracy. So we should be counting every single day. If we think about counting strategies, any time that we're standing in line with the kids, we're going to the gym or a liturgy, let's count how many kids are in the class. Maybe we have a group of kids over here, let's count how many kids are in this group. So anytime you have an opportunity to count, be counting with kids. And then let's also practice counting on from numbers. And it's really helpful if we represent the numbers on the board, right? So like 1, 2, 3, 4, we're counting 5, 6, 7, 8, 9. We're going to represent those numbers every time and we're going to talk about it. We're going to say, let's look at this 5. What does this 5 mean? What are all the ways that we could represent 5, right? Tallies are really foundational. Could we put them on a 10 frame? Could we represent it on a reckon rec, on a number rack, right, with the beads? Could we count 5 objects in our play center? Can we all of the different ways of representing 5? So this work should be done all the time. Record your thinking, talk about it, dig into the numbers, because we want kids not only to be able to count, but to be able to really deeply understand what 5 is, and be able to take apart 5 and represent 5 in different ways, put 5 together. We also want kids to be able to count backwards from 5. 5, 4, 3, 2, 1. We also want kids eventually to be able to count on from 5, 5, 6, 7, 8. So in kindergarten, you only need to go to 10, but this work should be ongoing every single day from September all the way until June, so that when kids go off into grade 1, they really understand the bottom of that framework. So that's all. I hope this helps. Email me if you have any questions, and have fun.